In my previous video, I have promised that I was going to upload an example under closed pipe. And here are the example under closed pipe. And we are going to see how we're going to solve these types of example. Okay, so it's very simple. This, what you are seeing here, is very, very simple to approach it the moment you know the formula very well. So let us go into it and see how we can resolve it. Okay, so the first example here, they said that the velocity is given as 327.68 meter per second, and then the length of this closed pipe is 16 centimeter. So they said the frequency is dash. So the frequency from this tuning fork, we don't know it. It's question mark, and that is what we are calculating. Okay, the frequency from that very tuning fork. The tuning fork is the frequency of that tuning fork is dash. That is what we don't know. So this is the fundamental frequency that we are looking for, because from this pipe here you find out that this is only 1/4. The sign here, this line shows only 1/4. In this case is different, but in this one is only 1/4 as the rule we use when we are proving it. Okay, so it simply means that the L, which is given as 16 centimeter, we need to convert it. This is 16 over 100, and we are taking it to to meter, and this is going to give us 0.16 meter. Okay, that means the length is 0.16 meter. But all of us know that the length L is equal to 1 over 4 lambda. Okay, so you need to substitute it direct. This is 0.16 equal to 1 over 4 lambda. You cross multiply immediately, then your lambda will be equal to what? 4 times 0.16. That is our lambda for now. But that is not what we are calculating. What we are calculating is the what? The frequency. We are looking for frequency. So for frequency, we must go back to the equation of wave. We say that the velocity v is equal to f lambda. Okay, so velocity is given. The velocity v is given as 327.68 meter per second. So we just make f the subject of the formula. F will be equal to v over lambda, and from there we can say our f is equal to 327.68 all over 4 times 0.16. Okay, and this is going to give us what? 512 hertz, and that is the frequency. Okay, so it means that the tuning fork here is having a frequency of 512 hertz, and that is our answer, as simple as that. Okay, so let's look at the second example. The second example is a different case, because they are asking us to look for what? The velocity of the wave. And if you look at the question very well, you find out that the L is given as 0.3 meter from the diagram there. The length is already given as 0.3 meter. So this one now, we are having how many quarter? 1, 2, 3. So we're having 3 quarters. So it simply means that the L is equal to 3 of lambda over 4, just as we explained it in the other video, the previous video. Okay, so if that is true, we can just substitute it straight by having 0.3 equal to 3 lambda over 4. We cross multiply here, so that we should have lambda will now be equal to 4 times 0.3. Then this is 3 lambda. Then you divide through by 3. If you divide through by 3, this by 3, this by 3, 3 will cancel 3. Lambda will be equal to 4 times what? 0.3 over 3. So if you have this, it's very simple. you don't need to even disturb yourself. This times this, lambda will going to give you 1.2 all over what? 3. You can leave it there because that is not the end of the story. You will go back to the equation of wave, that V is equal to what? F lambda. So we know that our F is what? 750 given here. F is 570 multiplied by 1.2 over 3. And finally, your V, when you multiply this by this and divide it by the 3, you will definitely going to have what? 300 meter per second. Okay, this times this divided by 3, this is the answer you're going to obtain. And that is it for today. It's very, very simple like that. If this is your first time watching this video, consider to go to YouTube and subscribe to my channel. And at the same time, you can share this with your friend on the WhatsApp